Right, so I believe this will have the real work for 6, 7, at least what appears in the homework. So this first part is reminding you that Arcsine has a limited domain. Its domain, and I'll highlight it here in yellow, is from minus pi over 2 to pi over 2. It cannot spit anything outside of that range out. Otherwise, it wouldn't be a function. Cosine is 0 to pi. Secant is the flip of cosecant is the flip of sine, so it's minus pi over 2 to pi over 2. Secant is the flip of cosine, so it's from 0 to pi, coming out there. Tangent has sine up top. It's from minus pi over 2, so he's grouped them in families really here. And cotangent's related to cosine, 0 to pi. So the left-hand side as you go down that column, all minus pi over 2 to pi over 2. Right-hand side, 0 to pi. Now, we're in a situation where you could look at these notes, I guess, as you do your exam. You absolutely want to memorize these. You cannot go to the next class and not know the outputs for inverse sine and cosine because you use them too much. Okay, and so he has a little grid here that you could study and try to memorize as well. And then some arc stuff going on there. Let's look at some examples. Here's how I would recommend doing it. If you have the arc cosine of -1/2, step number 1, know its output. Its output is between 0 and pi. It can only be in the first quadrant or second quadrant. You absolutely know it's in the second quadrant. Why? Because the first quadrant, everybody's positive. Second quadrant, only sine's positive, but namely cosine's negative, but you already knew that. 1/2, you already know that that has a reference angle of pi over 3 for cosine. And so what are you? You're looking at the second quadrant angle 2 pi over 3. The answer for this is 2 pi over 3. That's how you should navigate through it. Sorry about bringing that up. But let's watch him find 2 pi over 3, right? In that exact same way. Arcsine of -1/2. What do you know? You know the outputs between minus pi over 2 and pi over 2. Because you memorized it. Where are we? Well, we're definitely not in the first quadrant, so we must be down here. You know that it has a pi over 6 reference angle by memorization. And so what is this? Well, we cannot represent it as 11 pi over 6, even though that's a true representation of that angle. It must fall in between here. And so we're going to represent that angle in a negative manner as negative pi over 6. We're going to actually just say, hey, it's negative pi over 6 and be done with it. That keeps that 0 in there, and that's exactly what he has written there. And so that's what we're looking at. Arctan of 1. What do you know about arctan of 1? You know that tangent has sine up top, so it is also between minus pi over 2 and pi over 2. You just can't have those inputs, but you'll never have that. Arctan of 1, you know that that's related to 1's positive, so it's in the first quadrant, reference angle of pi over 4. You're finished. The answer is pi over 4 because you're in that first quadrant and the reference angle is the angle itself. That's how we're going to do this quickly as we go through. We're not going to need to look at charts. We just need to go back and look at the memorization. How about arc cosecant of root 2? Here's how I would suggest to do arc cosecant of root 2. Cosecant is the flip of sine. And so let me change something momentarily. This is totally the same as the arcsine of 1 over root 2 if you flip that, which is the arcsine of root 2 over 2, which you know is a pi over 4 reference angle. You know that sine, so I change all my cosecants into sines just like that by inverting this, because you know they have that flipped relationship. And so you have this nice pi over 4 reference angle in the first quadrant because it's positive, so you are finished. It's pi over 4. Now he doesn't mention going to sine, but that's what I do. Arc cotangent of negative root 3 over 3 has a pi over 3 reference angle, must be in the appropriate quadrant. So what's cotangent? Cotangent's cosine over sine. So we're looking for, actually it should be rounded, a 0 to pi, some output between 0 and pi. Well, it's not going to be in the first quadrant because it's negative. So that tells us right away second quadrant. I knew it was between the first or second quadrant. I now know it's second. I now know it's 2 pi over 3, and I'm moving on with my life, right? And we get a nice 2 pi over 3 out of that guy. It's awesome. So memorize those ranges, and it works really, really, really well. And nothing spits out outside of those ranges. So we're just, he mentions the ranges again because they're so important. And here we go, arc cosine of 1. It's between, well, you know that it's between 0 and 2 pi. Apologize, 0 and pi. Don't know what I was thinking there. Let me get rid of the 2. Those are the only places that it could have its output. When is the cosine equaling 1? Well, just picture its graph right at 0. So the answer is 0, right? And because if we go from 0 to pi, at pi, it's negative 1 coming through. If we look at that graph, this is the only segment of that graph. Arc cosine of 0 is going to be at pi over 2. The only time it hits through in that interval right at 0 is right in between there at pi over 2. So these are all right on the axis somehow. So when you see a negative 1, you're going to say to yourself, oh, you're on an axis. The question is, which axis? And we know that Arcsine's output is between pi over 2 and negative pi over 2. So it's somewhere out here. What's it going to be? To be a negative 1, sine corresponds to the y. It's got to be the negative pi over 2. It's that easy. So these quadrantal angles, the ones that end up right on the axis, are very easy for us to have to happen. So he's using arc sine, arc cosine, all the same, sine inverse and all of that. So he was using arc sines up here, arc cosines. I'm not sure at all what's different as we go here. It's kind of repetitive in there, but maybe he wants it just right before. I thought it was something new. And so we got arctangents and all of that. Yeah, so let's look at this arctangent one because there's a typo. We might as well look at it. Arctan of 0. So here's what I know about arctan. It goes from minus pi over 2 to pi over 2. At the minus pi over 2 and pi over 2, it's going off to infinity. Where is it 0 in that interval? Smack dab at 0. This is totally just a miscarryover. This should be tangent x is equal to 0. Kind of weird. But if that were to throw you off, that's what I saw. So arctan of 0 is equal to 0. So you can get these really, really fast. Arcsecant being negative 1. Let me show you how I would do number 17. I would change arcsecant to arc cosine. And I'm going to flip negative 1, and it's going to stay in negative 1. The answer to this is the answer to the arcsecant question. So then I can just ask myself, okay, cosine's output, that's between 0 and pi. Where is it going to be negative 1? At pi, right? Because at 0 it's 1, and so we're going to get at pi. Okay, and so we get a pi. I'm not sure even what's going on that it's not equal to pi over 2. Oh, that's the output, okay, because it can't have a pi over 2 output because it's undefined there. But make it easy on yourself as you go through. Cotangent being 0. The only way cotangent, see, this is weird. This should be a 0 right here. There's a lot of mistakes. So arc cotangent of 0. You're looking for the angle whose cotangent is 0. In my mind, I remember that cotangent of theta is cosine theta over sine theta. So all I have to do is find out where cosine theta is equal to 0 on the interval 0 to pi. Well, where is it equal to 0? We know. We have it memorized, or we can visually see it. Pi over 2. Done. Okay, coming through. So be patient with the typos that are in there. Now, these are super important problems right here. Arcsine, and these will make your test, make every test. Arcsine of sine of 2 pi over 3. Now, Remember the last thing to happen. You know the inverse functions should undo one another, and they kind of do. But the problem is the arcsine has a limited output. It can only go between minus pi over 2 to pi over 2. So the arcsine and sine ideally cancel each other out, and this is your answer. However, that's not in this domain, or that range, I guess. That's the better word for me to use it. So talk to me about 2 pi over 3. Sine of 2 pi over 3, is it positive or negative? Well, it's in the second quadrant, so it's positive. So this is a positive result. The answer is pi over 3. So pi over 3 would be, so what you know, and maybe I should take a step back. You know it cannot be 2 pi over 3. It is either pi over 3 or negative pi over 3. It's one or the other. The reason why we're choosing this one is because 2 pi over 3 is a second quadrant angle. And if it's in the second quadrant, sine's positive. Sine's positive here and negative here. So the arcsine is going to take that positive number and it's going to sine it back to the pi over 3. Now what's he going to do? He's going to painstakingly walk you through this, which is fine. You can figure out the sine of 2 pi over 3. It's root 3 over 2. Then you can take the arcsine of it, and it's going to give you the pi over 3. That absolutely is a way to do it, but we can be better than that. So let me show you his way first, and then we'll show you a more productive way. The first thing he's going to do is evaluate this and call it negative 2 over 2. Then he's going to replace that in for 5 pi over 4, right? And say, hey, what's the arc cosine? Well, you know that the cosine goes from 0 to pi, so you already know this is a second quadrant angle with a pi over 4 reference angle. And so you're going to evaluate that, and you're going to come up with 3 pi over 4. Now, what would have been better? Hey, my answer, it's these arc cosine and cosine undo one another. I'd be finished if 5 pi over 4 was in my output. But where is 5 pi over 4? It's right here. My output can only be between 0 and pi. So then I got to look at cosine of 5 pi over 4. It's negative. Where is cosine negative between 0 and pi? Second quadrant. So it's a second quadrant angle with a pi over 4 reference angle. It's 3 pi over 4. So you absolutely can figure out that middle piece, but the reason why you're not getting the exact same answer is because we're starting you out outside the range. So pretty cool in there. So what about this? Arctangent of tangent of 3 pi over 4. It's not going to be 3 pi over 4, but it is going to either be pi over 4 or negative pi over 4. Which one's it going to be? Well, let's talk about tangent of 3 pi over 4. It's negative. So it's going to be the negative pi over 4. Because that's also where tangent's negative. But the better part about the negative pi over 4, it's in the range, and you can see the negative pi over 4 right there. I'm sure you did this in your trig classes, and so I'm just bringing it up again that there's a really slick way to get these done, because that's what we want. We want thinking, not robotics. But we can definitely be robotic. Tangent of 3 pi over 4, second quadrant angle, pi over 4, it's going to be negative. Arctan of negative 1 is either going to go in the first quadrant or fourth quadrant. It's got to be fourth quadrant, and the fourth quadrant angle has to be represented by a negative, and we get the negative pi over 4 that way. I'll leave this one on the right hand side to you. Let's see what else we have. Awesome. Now here is where you can't just do the crossouts, because the problem with this is the sine and tangent are different. And so let's take a look at what tangent of 3 pi over 4 is. It's negative 1. And so what's the arcsine of negative 1? We'd have to go through it this way. There's no slick way to do this one. And maybe that's why he's doing them all that way. But I figure this is your second time learning this stuff. You want to start looking for those tricks. That's what gets you through the calculus. If you're bogged down on the trig and stuff, it's easy to fail, and we don't want that to happen to you. So let's take a look at this. Arcsine of negative 1. Well, that's going to be a quadrantal angle. So we know our outputs are between minus pi over 2 and pi over 2. It's the minus pi over 2 that has that y height of that. And so that's what we're coming for here. Arcsine of -1. So this should be interesting. This should be sine x is equal to -1 on the interval from minus pi over 2 to pi over 2. And what are we getting out of that? We're getting negative pi over 2, and he has a 4 there, so it's super confusing. This is negative pi over 2 coming through there. Sorry, I had a hair on there. You can't see it, but I can. And then if we look at example 24, same thing. We're just going to evaluate sine of minus pi over 3. So we're going to take the arc cosine, and we know what sine of pi over 3 is. It is root 3 over 2, and because it's in the fourth quadrant, it's negative. Well, arc cosine is going to put that guy in the second quadrant. So we got to ask ourselves, whose cosine is negative pi over 2? Well, that's a pi over 6 reference angle. In the second quadrant, we're done. Sorry. Started writing 5 twice. 5 pi over 6 should be our answer. And it is a 5 pi over 6 answer there. So really there are two problems in one. You can handle it just like that every single time. And so these are the strangest ones here, when they pick numbers that we really don't know. And so, but they're easy. Easy. So hopefully you remember, he hasn't brought it up yet, SOHCAHTOA. That's going to help us out a lot. So I want to show you a very nice way to do this. So if you got arc cosine of a negative number, you should know right now that you are in quadrant 2. Now cosine, what's cosine? Cosine is adjacent, so my adjacent side is -3, and my opposite side is 5. What I need to figure out is this side right here. And so if I solve for this side, you could use the Pythagorean Theorem, but maybe you remember that it's a 3, 4, 5 right triangle, right? But I could use the Pythagorean Theorem and say, hey, I need to know what that y height is. Now, do I need that? Sure, because tangent is opposite over adjacent. So here's the angle that we're considering, right? We always can reference the reference angle. And so opposite over adjacent is 4 over -3. Does it make sense that tangent's going to be negative in that quadrant? Absolutely, because it's the second quadrant. So let's take a look at what they come up with. They come up with the same -4/3. Perfect. That's what we have come up with, -4/3. Let me get back down to where we were a little bit farther. So in example 26, arctangent of -5/12. Where is that at? I'll draw it in red this time. It's down here. Because you know arctangent can only spit out in the first and fourth quadrant. You know tangent is opposite the negative over adjacent 12. Hypotenuses are always going to be positive. And you shouldn't be surprised that the 12 is positive because it's going in the positive x direction. The 5 is negative because it's going in the negative y direction. And this is going to be 13 if we did the Pythagorean Theorem. If you did 12 squared plus -5 squared equals c squared, you're going to get 144 plus 25 for 169 is equal to c squared, and c is always positive. So we get a 13 out of that. So what's the sign? Sine is opposite over adjacent. You're done. It's -5/13. And so they're just looking to reinforce some of the right triangle trigonometry that's going on in earlier classes. So pretty cool. And then these ones right here you can skip. I didn't assign any of these in the homework. They're definitely not on the exam as well. So you can skip from this page down. There's not a lot of reinforcement of it later on, and therefore, not really a great use of our time. It's pretty much the same thing as what we were doing, but I promise you I'll stick with numbers on the exam. So you do not have to do page 11 and 12 or study that. You'll be fine even as you go through the homework.